Good morning, Sam.
Morning, Michael.
Good morning, good morning, good morning. How do you like to store information at home? Like, do you have a hard drive? Do you store stuff in the cloud? Are you sort of a print it out and file it kind of person?
I think it kind of depends on what it is. I put some stuff in the cloud, but I have some things, home movies and stuff like that on the hard drive. I think even today, going back to writing stuff down is almost a little bit more safe if it's really, really important. What about you? What do you use? I feel like you probably have multiple hard drive backups of literally everything.
I feel so seen. I have a NAS, networked attached storage, which has 4 hard drives in a RAID. I live by the rule of 3, which is you have 3 copies of any file you don't want to lose. So now, Sam, while these sort of backup methods might work for regular everyday people like us, when you scale it up, the quantities of data that you have to store in organizations and the methods you have to use to store it properly can become significantly more complicated. So this week, we are diving into the topic of data storage, and in particular, data storage in the world of AI. I'm Michael Bird.
I'm Sam Jarrell.
And welcome to Technology Now from HPE. We've talked a lot about storage on this podcast over the years, how you store data, where you store data, that sort of thing. But do you know how much data we are creating nowadays?
I'm sure it's going to be some sort of made-up term plus the word byte. I'll be fun and we'll call it a zeta-beta byte.
Dodecahedron byte, that sort of thing.
Dodecahedron byte. I like that one better.
Dodecahedron byte. We should copyright it. Now, according to research from Petrock Taylor in 2025 and published on Statista, by the year 2020, we were creating and utilizing over 64 zettabytes, there's the word, Sam, zettabytes of data. And in 2022, that number had risen to over 100 zettabytes. And predictions put last year's data at over 180 zettabytes. Now, to put that completely arbitrary word into perspective, the latest smartphones can have 1 terabyte of storage, and to get to 180 zettabytes, you would need over 100 billion smartphones.
Wow.
So that's a lot of smartphones. And we have, of course, linked to all of these stats, as well as all of the other sources in the show notes.
Call that big data. My goodness, that's a lot of phones. It's a lot of data. I'm sure not all of it is high quality data either.
Most of the data we create and use isn't designed to be stored long term. However, as the use of things like artificial intelligence continues to rise, this is beginning to change because, as you know, AI both uses and can also create huge amounts of data which needs to be stored and then processed, and organizations often don't want to dispose of this data until they can confirm they no longer need it. So, to find out more about data storage in this era of AI, I spoke to Jim O'Dorisio, Senior Vice President and General Manager, HPE Storage.
But before we speak to Jim about modern day storage technology, I want to take a look at how we got here and some of the designs which didn't quite make the cut. It's time for Technology Then. The art of storing data goes back to the birth of civilization itself. We've always needed ways to record information. Books, libraries, and clay tablets were all ways in which people could preserve knowledge, but digital memory is obviously a much more recent concept. Michael, do you know what was the first fully electronic memory? And do you want to guess when it might have turned up?
Okay, I'm going to say 30s.
Not a terrible guess. Most computers were beginning to come into their own post-World War II, but the mechanical memory, which is made of moving parts, was causing progress to stall until 2 researchers, Freddie Williams and Tom Kilburn in Manchester, England, created a tube. But this tube was special. Inspired by cathode ray tube storage, which Williams had seen during a trip to America, the Williams-Kilburn tube became the first entirely electronic memory, and it worked by storing bits as dots on the surface of the tube. Like with a cathode ray tube in a TV, the Williams-Kilburn tube required constant refreshing by the cathode ray to stop the dots fading and disappearing. Information on the tube could be read using a metal pickup plate near the screen, which would detect a change in the electrical charge when the cathode rays swept across the screen. However, the Williams-Kilburn tube faced a few issues which would eventually turn out to be pretty insurmountable. To keep it working, a Williams-Kilburn tube would have to have been hand-tuned frequently. They were also notoriously sensitive to the environment and could be interfered with easily, so when they were excellent when they worked, their unreliability was kind of a huge issue. So even though they were so good that they were used at, for example, Los Alamos, the Williams-Kilburn tube finally fell out of favor and was replaced by a magnetic core memory.
Yeah, I think storage is something that you want to be somewhat reliable. Yeah, I don't think you're going to want to be hand-tuning things.
No.
Now, today we use semiconductor memory, and you might have heard of things like DRAM or dynamic random access memory, but the world is still changing faster and faster. So, to find out more about where we currently stand, I spoke to Jim O'Dorisio, Senior Vice President and General Manager, HP Storage. And the first thing I asked him was how storage has had to evolve in the past decade.
It has been an interesting ride, to be honest. If you think about 10 years ago, there was a major move of workloads into the public cloud. So there's a major migration of workloads, along with it, storage into the public cloud. At the same time, there's been this explosion of data, unstructured data in particular. It's estimated that about 200 zettabytes of information would be created in 2025 alone. It's mind-boggling. But as that's happened, and storage is becoming more intelligent, and it's having to become much more performant, workloads are being moved out of the public cloud and back on-premise because there's data sovereignty issues, there's security, there's performance. And then with the age of AI, it's much more important for our enterprise customers to have sovereignty over their own data.
And you talked about petabytes and petabytes of data. Has the type of data we're creating changed? Like, are we creating more unstructured data?
Well, and if you think about customer data, if you think about audio and video, all of the data that gets generated from a social media perspective, but increasingly it's a richer data set that we interact with our customers with. All that data is getting stored. Everything that might have been paper transactions 20 years ago is now digitally transacted. So all of that data is available, accessible, and really available for insights to be extracted from.
And presumably the rise of AI has had quite an impact on just the sheer amount of data we're creating.
Yeah, sure, it does. And it has a huge impact on what we save, because obviously storage has become much more efficient and much more intelligent. So you can automatically store more. Solid state devices, flash devices, they're faster, they're more reliable, they're getting larger and larger. The ability to store massive amounts of data efficiently is increasing every year. And as such, customers can store more data, and they can contemplate what they want to do with the data and how they can leverage it for competitive advantage.
And how did the migration to cloud, and I suppose perhaps the migration in some instances away from cloud storage, how has that impacted the way that we think about storage?
You know, I think initially everything was going to the cloud, and I think there's a bit of an equilibrium now. But AI in particular is forcing customers to consider pulling data back into on-premises, because there's the ability to operate on the data with the security, the performance. It has placed new requirements. And so you are seeing some elements of data moving from the cloud back into on-premise locations.
I want to dive into AI in a bit more detail. It's still the buzzword at the moment, isn't it? And so why, when we think about AI, is storage so critical?
Well, certainly the sheer amount of data that's being generated is critical, but the ability for storage to evolve and become much more intelligent and supporting these AI workloads is becoming much more critical. From an intelligence perspective, we're talking about being able to add metadata as the data is stored on the storage layer.
Right. Okay.
Right.
Yeah.
And certainly, you know, the ability to do things like calculate vector embeddings as the data is being stored, because then the data is ready for AI operations as it lands on media. And that's a huge advantage.
So what we're saying is actually you're taking that piece of data, you're loading a load of metadata, lots of additional information, which the AI algorithm can use to do something with.
Exactly.
And it can do that faster.
And they can do it faster because the idea of the intelligent storage layer allows the data to be AI ready. In the past, if you had a less intelligent storage layer, you would have another post-processing activity. You would store the data, and then you would run it through a GPU, and you would calculate vector embeddings, and you would do those sorts of things that would allow you to do inferencing and RAG across your data. Those sorts of things can be done as the data is stored with an intelligent data storage platform like the ones we have here at HPE.
Are the different categories of data which we discussed before all being used here, or does AI focus on just like sort of one or two of them?
We're talking mostly about unstructured data, and it could be anything from contracts to analysis of contracts, PDF files, multimodal data, data that has audio and video.
Stuff that traditionally, before AI, it would be a very manual job to make sense of.
Extremely manual and limiting in terms of the kinds of value that you would get out of the data and the speed at which you could derive those insights.
So storage is sort of the foundation that AI is built on.
Well, increasingly, it's super important because we started off with GPUs and compute nodes in servers, and that continues to exist. But now companies like HP are building intelligence into the data storage layer. It's becoming essential because it allows the processing of the information and the value of the data being extracted to happen that much more efficiently and that much quicker. So it's very foundational at this point. And as we talk about zettabytes of data being created yearly, it's important that we have a flexible infrastructure, that it exists. We talked about data has gravity, that we can deploy that infrastructure where the data exists, where the data is being generated, that we have the processing of that data local to where the data exists. So having this flexible, powerful infrastructure and really relying on the intelligence that the storage layer can deliver is absolutely essential.
So we sort of talked about storage helping with AI, but how can AI be used to sort of improve storage?
At HPE, we literally use agentic AI in our storage products, and it's used to improve the operational efficiency of our storage. It's used to do things like improve the proactive support experience for our customers. It's used to solve problems before customers even experience the problem. I like to say some of the best AI that we've written, language models we've written here at HPE, actually are running in our storage layer.
And that's sort of doing the jobs that previously would be, again, pretty time consuming.
Less proactive, less efficient resolution of challenges for customers. And increasingly, customers want this self-healing, self-managed infrastructure, and having AI built into the storage layer allows that to become more of a reality.
Yeah, and not just your disk drive is about to fail, more intelligent than that.
Yeah, right. Exactly right. Yeah.
Because that's what it used to be. It used to be your disk drive is about to fail and you go, oh, this is great.
Or it fails and you log a case and somebody shows up. But now, much more proactively, we're looking at a lot of data minute by minute to predict what's going to happen as opposed to waiting for it to happen.
And I suppose, is there looking at trends in how, say, I don't know, a storage array is being filled up? For some reason, there's one site that's generating lots of data. So maybe actually on that site, want to increase the storage in that.
What we've built into our systems is the ability to identify performance hotspots, to do trending analysis, to understand this noisy neighbor problem where you might have certain workloads that are impacting the performance of storage, and then making automated recommendations to customers to how to modify to get better efficiency out of the storage.
Right. Okay. Basically, make the most of the investment you've got.
Exactly. Really giving the customer the information that they need to be as proactive with their infrastructure as they possibly can be.
Because I think maybe 2 decades ago, there was a sense of just buy as much as you think you might need. It wasn't particularly intelligent. I realize we're just talking pure storage here, but I suppose actually if you could be more efficient with it, you could make more of your money.
It's all about efficiency because enterprise budgets are not increasing. We have to carve out funding to go do AI projects. And so it's that much more critical for the infrastructure to run efficiently and to really provide the kind of ROI a customer requires.
Can I talk data sovereignty? How are storage and sovereignty linked? It feels like a very obvious question.
Well, sovereignty is becoming much more important, especially in the age of AI, and especially in Europe, where rules and regulations at a country level prevent data from leaving the country that it was created in. And so having a storage infrastructure that's flexible, that can be local to where the data is generated is absolutely critical. And from an HPE perspective, we're doing a really good job of that.
Do you expect to see more conversations around sovereignty in the future? And if so, how will we respond in terms of the way that we create things, the products that we're creating? How will that maybe perhaps change?
From a sovereignty perspective, I think we can expect more concerns and more regulations around sovereignty as the world becomes much more complex and countries are much more concerned about data leaving their borders. So I think from that perspective, our ability to deliver our management capabilities that run locally, it creates a particular challenge for some of the public cloud providers because their infrastructure exists in virtual places and it's very difficult sometimes to ensure the data doesn't leave a particular country. And I think it has the effect of driving critical content back on premises because organizations can control it there. They know where it was created. They know where it's stored. They can put compliance around it.
And will there be more emphasis on, say, reporting on that data?
I think based on the way you built your infrastructure, it's very auditable. You know, where your infrastructure is, the arrays sit within your data center or they sit within multiple data centers, all within your country. I mean, if it's under a customer's control, then it's very easy to determine. When you get in a scenario in a public cloud where you're pushing data that you think is in a data center, but it's replicating to another country, that's a fairly common thing.
All right. I want to ask the question that every technologist hates to be asked, which is, where do you see the world of storage in, say, 5 or 10 years' time?
Over the next 5 to 10 years, you're going to see faster solid-state disk drives. You're going to see more intelligence built into storage. You're going to see larger and larger capacities over the next 5 to 10 years. And you're also going to see a lot of advanced development around things that probably won't come to market in 10 years, but you'll see a lot of advanced development around holographic storage, around DNA storage. You'll see a lot of development in those dimensions, yes.
Because Moore's law has only got, I'm guessing with storage, we're miniaturizing. We're talking flash storage.
You know, obviously, as you think about the efficiencies of NAND and the ability to store more and more data in smaller and smaller footprints, you're going to see capacities continue to accelerate. So you're going to see performance, capacity grow, which along with the intelligence that will continue to build into the storage layer to support these AI workloads.
Will we start to see water-cooled storage, do you think?
Oh, absolutely. I mean, certainly we have at HPE, we have water-cooled racks, we have water-cooled everything. And I think as you build more intelligence into the storage layer, you know, you'll see GPUs running in storage and you'll get to a scale where, you know, water cooling will likely become much more prevalent even at the storage layer.
Jim, thank you so much for your time. Thanks for coming on to Technology Now.
Well, thank you. I enjoyed it. Thank you very much.
Wow. The idea of holographic and DNA storage is pretty crazy to me.
Yeah, I thought the same thing. We did an episode where we talked to a researcher who was doing DNA storage. I want to come on to different storage methods in a bit, but my big takeaway, which I think we all know and we've talked about many times before, is AI is all about the data. We talk about good data in, good data out, bad data in, bad data out. But fundamentally, you need somewhere to store all that data and you need to process all that data. And we did an episode a few weeks ago where we talked about networking and talked about how like networking needs to be running really efficiently. And this conversation, the same is true of storage.
Yeah, that's true. Basically, it seemed as though storage with AI was getting closer and closer to the time of the creation of data to leveraging it efficiently. And so that to me just sounded a lot like the edge, which we normally think of in the context of networking. So it's all kind of starting to become the same thing to some degree, especially once you start talking about using GPUs in storage. It all seems like networking, storage, and AI and compute are all just one kind of cohesive thing at a certain point.
I remember storage arrays, like one of the big selling points is it will let you know before a component fails. And I think Jim said it'll call up the supplier and it will say, my hard drive is about to fail and one will get shipped out to you. And that was sort of the extent of the intelligence. But actually, that's just like one element of it. There's so much more that could be optimized, could be tweaked, could be fixed. And again, just like as you talked about, actually managing that infrastructure can be quite a burden to IT departments. Again, as Jim said, the budgets haven't got any bigger. So we have to do more with less.
Yeah, that's true. I love what you brought up, though, about it letting you know about support and whatnot. Like at the time, I could see where that felt very, very useful, but anymore, like the standard changes, right? Like now I imagine as they have these different self-healing products and storage arrays that it's like, don't just tell me, do something about it, right? Like do it right now yourself.
Yeah, just go in and do it.
Yeah.
I think the conversation at the top of the show that we talked about storage needing to be more intelligent in the world of AI and essentially like loading metadata onto the data. He used the phrase vector embedding. It's a metadata. It's a piece of information that will go with whatever it is to make processing that data even faster. And again, we've talked about this on the show before. AI is about speed. AI is about making the most of the resources that you have.
That makes me happy, actually, because it makes me think of maybe like there's a whole sustainability component to all of this too. Because in the past, you would just buy lots and lots of physical storage, or you'd expand endlessly into the public cloud, which was also costly and crazy. But now you're at least optimizing everything so that you're using exactly what you need and not necessarily going overboard with what you don't.
Yeah, exactly. Now, Sam, as you said at the top of the show, technologies can rise and fall as times and systems changed. And actually, that does touch on one of the things that I really wanted to ask Jim about.
Oh, what's that?
Well, I wanted to know if Jim thinks that hard drives will disappear one day. Because, it's all flash storage now, isn't it?
It's an interesting question because 25 years ago, if you would have asked me, would tape still be around? I would have said probably not.
But it still is.
It still is. And I've heard it said that tape is dying at a glacial pace, right? So I think there's maybe a parallel there from spinning disk, but at some level, it'll become too inefficient to make spinning disks because there's a lot of technology there. And as the footprint shrinks down from an SSD perspective and you can store more and more information, I think the prices will start to converge and at some point it won't make as much sense.
Interesting. Do you think it'll die a death at a glacial pace too?
I think it'll take some time. It's not going to be this year or next.
That brings us to the end of Technology Now for this week. Thank you so much to our guest, Jim O'Dorisio. And of course, to our listeners, thank you so much for joining us.
And if you've enjoyed this episode, please do let us know. Rate and review us wherever you listen to episodes. And if you want to get in contact with us, send us an email to technologynow@hp.com. Subject line, zettabytes.
Dodecahedron byte.
Dodecahedron bytes. And don't forget to subscribe so you can listen first every week. Technology Now is hosted by Sam, Jarrell, and myself, Michael Bird. And this episode was produced by Harry Lampert and Izzy Clark, with production support from Alicia Kempson-Taylor, Becky Bird, Drew Lietzo, Alyssa Mitri, and Renee Edwards. Our theme music was composed by Greg Hooper.
Our social editorial team is Rebecca Wissinger, Judy Ann Goldman, and Jacqueline Green. And our social media designers are Alejandra Garcia and Ambar Maldonado.
Technology Now is a Fresh Air production for Hewlett Packard Enterprise. We'll see you the same time, the same place next week. Cheers.
Bye, y'all.